So, mm, so we have basically seen that how a recursive function works and what does recursion mean. We have also realized some limitation of this recursive function. Now we will start a totally different part of C language, that is what we call structure. So what is a structure? First of all, structure is a memory location. Okay, structure is a memory location. Now, how the structure look like and what does it mean? To realize this, let's start from a very basic data type we started. We started from int, char, float, something like that, right? Let's start here. So we started from int, char, float, all the data types. These are what? These are what actually you can say data types, and we started with uh, you can say declaring a single variable. For example, what does single variable mean? Single variable, what I mean that say int a, or you can say char ch, something like this. Now, what is the disadvantage of doing this? Disadvantage means you can say limitation. What is the limitation of this? You can say as a limitation, we can store only one value at a time, right? That means if you write a equal to 10, 10 will get stored in the variable, and then after if you write a equal to 20, 10 will vanish and 20 will be replaced by 10. I mean sorry, 10 will be replaced by 20. So 10 will vanish. That means you cannot store 10 and 20 at a time, both. That is why the solution that we have seen is concept of array. So it can be array of integer, array of character, array of float. So what is the limit? What is the limitation for this array now? Limitation for array, you can say that although yes, we can store more than one value at a time, but we cannot store data of different data type in a single space. What does it mean? For example, record of a person. Record of a person may include its name, his phone number, his age. For example, record of a student like you. If I want to store the record of all the students of say class of some class, that record may contain the student's name, student's address, student's contact number, student's age, and many more, and maybe the marks of the students, right? So if you closely watch the data type of all these different information that I have said, you will see that they are not of same data type. Some of them are string, something like character array. Some of them are integer, some of them are simple value. For example, your age is integer, so only single variable is sufficient. But your name should require a character array where you will store your name as a string. If I want to store your marks of your different subject, then I need to store an array of say 5 or 10 length, depends on the number of subjects that you have in the current semester. But the data type of the array should be float, because marks can be in point, percentage can be in a point, and many more. So there is no such data type as if which can store all these different data type at a whole. To get a solution for this, actually the concept of structure came. What a structure does, structure actually encapsulate all these different data types in a single space. Now how we write a structure? Let's write it. We write a structure in this way. The keyword for the structure is struct. Okay. Struct. Struct. Say for example, I'm writing record. Okay. Struct record. And within this, I can write, say for example, char name, say 30, for storing your name as a string. Say for example, int age. Then for example, I can write float marks, say 5, because suppose you have 5 subjects in the current semester. So we can write a structure in this way, but now question is that how I can use this. To realize the use of a structure, how the structure actually is used, can be used in a program, we have to understand what is the physical interpretation of this one. Just try to realize it one thing from an example. Suppose that there is an open land somewhere. Assume there is open land somewhere where you want to build your own home. So you have bought the land and you will have some plan, right? Where you will have a kitchen, where you will have some dining room, where you will have a bedroom and so on. And according to the plan, you have started developing the building. So according to the plan, the building will be developed. So whatever is shown on the plan will physically exist when the building will be developed fully. So with respect to structure, the plan that we have is basically the structure that we are writing in this particular mode. If you have a plan in your hand, it doesn't mean your building is created. A building has been developed fully, right? It is not possible to stay over there building construction is not completed. When the construction will be completed, then you can stay over there, not before that. But when the construction is not completed, you have the plan in your hand. So having a plan of some building in your hand does not mean the land that you have is occupied. Right? Now the story that we are talking about for last 4-5 minutes, just try to realize, just try to map this story with respect to the concept of structure with respect in a C program. How we will map? The plan that we are talking about is basically the structure. The plan that we are talking about, where your building is constructed, is land is basically your memory space. And the building that you have that physically exists and will follow the same structure present in shown in your plan, that building is basically an instance of the structure. What does instance mean? Instance mean, again let's try to realize from the example. Suppose that you stay in Kolkata and you have a number of lands in different places of Kolkata. Okay, just open land. It's not, no building is there, no construction is there, and you have only one plan in your hand, and with that plan you have designed the buildings in those all places. Now if you visit all those different constructions, what you will see? You will see that by the architecture each and every construction are same, because they have followed the same plan, same plan on your copy, present on your copy, right? But will their address be same? No, their address will not same, right? That mean the instance is basically a physical interpretation of a structure, one physical interpretation of a structure, you can say. In this way, you may have multiple instances of the same structure. So that means, now how I can create this instance? We can create the instance in this way, something like we can write struct record R1. I can create another instance again, struct record R2. This is another instance, or you can keep within a comma also. Now what will happen with respect to a memory point of view? If you say that the whole thing is a memory space, this is what your plan is. It doesn't really exist on your memory. What exists? This instance exists. And this architecture of the instance will look something like this, because these instances are of this particular structure. So assume that this is your building plan, and this R1, R2, R2 individual construction whose architecture is same according to your plan. So physically this structure does not exist, but this R1 and R2 exist. That means when this you will write, if you write this structure and run the program, there is nothing on the memory. But when you will write these two statements, and run the program, what will happen within the memory, two structure instance will be created. Two structure instance. Okay. Where this is instance R1 and this is instance R2. Where this instance contain name, age, and marks. Similarly, this particular instance will also contain a space for console, keeping a name, an age, and a space for marks. So by structure they are same, but they are physically apart. That means address of this R1 can be 100 and address of this can be 200. Since they are physically apart, obviously the this is name, this is age, and this is marks. Right, this is name, this is age, this is marks. Obviously this age of R1 and age of R2 is not same, may not be same, may be same. They are not related with each other at all. Anyhow. Okay. And now how we can access this age? We cannot write, if you write say printf %d, suppose that printf %d age, it's wrong. You will get syntactical error. If you write printf %d record dot age, it is also wrong. We have to write, if you want to access a particular variable of some structure, we have to use with respect to its instance name. So it should be R1 dot age, something like this. So there is we can note one thing. We can write that to access, I'm sorry, to access the variables of an instance of a structure, we use dot. I must write dot. Dot means dot operator. This one that I have written. Dot operator. This is correct. Not only for age, not only for anything. For example, if I want to just, for example, print the marks of this student R1. This student R1 is a student, R2 is another student, R3 will be another student, something like this. Like If I want to print the marks of student R1, how I can write it? I can write a simple for loop for I equal to say 0, I less than equal to 4, because total number location are 5, I plus plus. Suppose that there is some marks. Okay, I'm not inserted. Anyway, I've just shown you to realize, to show you, I've just shown you to realize that how it is accessing. I can write that printf %d R1 dot marks of I, because marks is a array. So this variable we are habituated how to use a array. Now when it will within a particular structure, we have to use the instance then dot, as simple as that. And after instance and dot, the use of the variable is same as we have already done in previous classes. So in this way, this is a very basic use of a structure. Now we have many more complicated things regarding we have in a structure. For example, that means one thing is clear. I mean, if we just between the after this, that what I can say, that the data type that we have seen till date, a data type can be categorized in two ways. Data type is categorized in two ways. One is called predefined data type, and one is called user defined data type. What does predefined means? Predefined means how much memory it will occupy, that is defined. For example, int, char, float, you cannot change by yourself in a particular compiler. For example, Turbo C++ 32-bit compiler says that int takes 2 bytes of location. That's all. That's fixed for that Turbo C++ 32-bit compiler. No programmer can change this. But what is an example of user defined? So example is int, char, float, and many more. An example of user defined is the one we have already seen, that is structure. Why? The reason is that there is no definition of a proper, there is no definition about a structure, that how many type, how many locations, I mean, what is the memory, I mean, total memory locations it can occupy. You see, in this struct record, I have written 3 variables, right? But there is no guarantee that every time a record structure will have 3 variables. It totally depends upon the requirement. For example, in case of another structure, if I want to store more information about the student, not only name, age, and marks. For example, I want to store their address. Then I will need another array, character array. If I want to store, for example, their contact number, I need a long int variable, and many more. So with respect to that, the memory location that a particular structure instance of the structure will occupy will be defined. For example, if I ask you that what is the total memory space R1 will occupy or R2 will occupy, how you will understand this? We have to go through the definition of the record structure, and according to that we have to declare this. We have to find this. For example, in this record structure, char name, we know that char take 1 byte of location, int take 2 byte of location, and float take 4 byte of location. So it totally depends upon Turbo C++ 32-bit compiler. This is a standard compiler, that's why we use this. So according to this char name will take total 30 byte, this will take total 2 byte, and this will take total 5 into 4, 20 byte, right? This is 30 byte, 2 byte, and 20 byte. So as a whole, it is 30, 50, 52 bytes. That means this R1 structure will take 52 byte location. Same for R2. Now this 52 byte is not fixed. Not fixed in the sense, this 52 byte is not fixed for this record structure. If you introduce one more variable, for example, if I write a record structure like this, say char name, char name 20, char address 30, int marks, say from 10 to last. So lot of marks will be there, say 10, int age. Okay, and so on. So suppose that these are sufficient. So now if I just create a structure instance of this, say struct record R1, then how many bytes it will occupy? This will take 20 into 1, 20 byte. This will take 30 byte. This will take 10 into 4, 40 byte, and this is 2 byte. Total 20 plus 30, 50, 90, 92 byte. That means this R1 will occupy 92 bytes of data, 92 bytes of memory location. Now, as the number of instances will increase, as we will define the number of instances, obviously all the instances will take 92 bytes of location. By the way, I'm sorry, it should be not 40, it should be 20. I have a mistake, it is int. So anyway, it is 20 plus 30, 50, 72. So it's not 92. I'm sorry, it should be 72. Anyway, so 92 or 72 is not important. What is important is that the structure, what is the length of the structure is not fixed. It depends upon how many primitive data types are present within this structure variable. Okay. So this is all about a very basic idea of structure. Now we will see in the next class then how we can use this concept to work with records, for storing records in near future.